Hello, everyone. Today we are going to talk about 9.2 graphs of piecewise function. In today's lessons, we will work specifically with piecewise of linear functions. Remember, linear means a line, or those that can be comprised of linear segments. A piecewise linear function is a function with different rules for different domains. Remember, domain means your x value. Piecewise linear functions are more complex function rules. One way or another, though, they fit the standard definition of function. For every value in the domain x, there is one and only one value in the y range. So we are going to consider the function defined by f of x equals 2x plus 4 when x is greater than or equal to negative 4 and less than or equal to 1, and 6 minus x when x is between 1 and 5. So how I like to do this is I'm going to take this top part of the rule and I'm going to make a table. So my x values go from negative 4 to positive 1. And then remember, I can use my calculator or I can substitute them in, but I'm going to find the function. And for that top rule, I'm using the 2x plus 4. So if I use my calculator to do that, I go to y equals and I enter the 2x plus 4. And when I'm looking at my table, I'm only looking at the ones I put in my table there. So I'm starting at negative 4. So negative 4 is negative 4. Negative 3 is negative 2. Negative 2 is 0. Negative 1 is 2. 0 is 4. And 1 is 6. So I'm going to plot those points. Oops, I did positive 4, not negative 4. Now I need to focus on, because what I'm doing is I'm making an inequality rule. So these are both included. So these are both solid circles. So I make sure they're both solid circles. And then I'm going to connect just those two with a line segment. So there's the first part of my piecewise function. Now I need to do the second part. So for the second part, I make a new table. And for this table, I'm only doing from 1 to 5. So again, I can use my calculator to get those values, or I can substitute them in. But on my calculator, when I'm x is 1, y is 5, 2 is 4, 3, 2, 1. So I plot those. Now when I'm plotting it, I'm noticing at 1, it's not equal to. So when x is 1, it's not equal to. So that means on the circle 1, 5, I put an empty circle. And then I plot the rest. And I connect those. The empty circle there at 1, 5 is really important because that's how I make sure that it's still a function. Because in order for it to be a function, I can only have one value when x is 1. And because that's an empty circle, when x is 1, the answer is always 6. So now we're going to state our range. So our range goes from negative 4 up to positive 6. And that's the graph of the piecewise. So now for example 2, we're going to, again, I'm going to make a table. And I'm going to start. This is x is less than or equal to 1. So it starts at 1 and it keeps going forever smaller. So it's important that I go less than or equal to 1. So again, I'm going to use my calculator to complete that table. And so when it's 1, it's 1. 0 is 3. -1 is 5. -2 is 7. -3 is 9. So I'm going to plot that, and notice at 1, that's a solid dot. So I can note that in my table if I want. So 1, 1 is a solid dot, then 0, 3, -1, 5. And it doesn't all fit on my graph, but notice that it's just always less than 1. So I can do an arrow because that keeps going. Unlike in example 1, it had a beginning and an end. So now I'm going to do the second part. The second part is when x is greater than 1. So I'm going to start at 1, but there, since it's greater than 1, I'm going to put an empty circle. I'm just going to pick numbers greater. And my rule is 2x minus 1. So again, I can use my calculator to help me with that, or I can calculate it. So when x is 1, that equals 1. 2 is 3. 3 is 5, 7. So 1, 1 is the same point. So 2, 3, 3, 5. And it starts at 1 and continues upwards. So evaluate each. So here I'm going to use my graph. So when I'm at 5, I'm over here. So I'm going to be on my blue curve. So I'm going to do 2 times 5 minus 1, which is 9. When I'm at -2, I'm on my purple curve. So -2 on my purple table is 7. Carefully evaluate f of 1. Well, I actually don't need to be in both equations, it equals 1. But I should use the top one because that's where x equals 1. So this is 3 minus 2, so it's 1. You need to use the function where x equals 1, which is the top one. Piecewise linear functions can often have horizontal components as well as slanted. They will obviously never have vertical components or they wouldn't be a function. Let's see if we can translate from a graph to a piecewise function. The piecewise function f of x is shown below. So find the slope of each part. So the slope of AB, I'm just going to count. So I go up 3 over 2. BC is horizontal, so that has a slope of 0. And CD, I go down 2 over 4, or -1/2. Now find the equation of the line that passes through each of the following pairs of points in y equals mx plus b form where applicable. How can you find the y-intercepts by using the graph? So how I'm going to find the y-intercepts is I know my slope is from a to b is up 3 over 2, up 3 over 2. So I'm going to do that again, up 3 over 2. And it passes at a precise point. So therefore the y-intercept of AB is 3. So that means the slope of AB is y equals 3 halves x plus 3. BC goes through the y-axis at 3. So the slope y-intercept is 3, has a slope of 0. So that means BC is the equation y equals 3. CD had a slope of -2 fourths or -1/2. So I'm going to do the reverse. Up 1, left 2. So CD has a y-intercept of 4. So that means it's the equation y equals -1/2 x plus 4. Now we're going to write a formal piecewise. So the other parts we need, not only the equation, but we need the x values for which it's those values. So we're going to say f of x equals 3/2 x plus 3. Now, at our points where they intersect, we only want one value there. So I'm going to say that I'm going to include those values on B and C. So for 2/3 x plus 3, it starts when x is -6, and it's equal to, because that's a solid. And I'm going to say that it's less than -2, because again, I can't have two equations at one point. Then it's 3 from -2, and I'm going to say x equals -2, and x equals +2. That's the part in the middle. I want you to pause and define the last part. So the equation for the last part is -1/2 x plus 4. And my my domain, my x values, is from +2, just less than, to less than or equal +6. So we will do this last exercise together tomorrow in class. If you have any questions, please ask that.